Okay, continuing with our discussion on section 2.3, we've already gone through some mixture problems. This time, let's see what we can do about the distance, rate, time, which is sometimes called uniform motion problems. Uniform motion problems are based on this particular formula that whenever we want to get a distance, remember that a distance is equal to rate times time. Rate times time, which most people might recognize in the formula form d is equal to r times t. What does that mean? Well, if we're traveling at a rate, let's say 35 miles per hour, and we're traveling for a certain amount of time, a number of hours, then we're going to get a distance in miles. So we're going to get distance, rate times time. Now, we have in this problem a car leaving a town, traveling at 35 miles an hour, and then 2 hours later, a second car leaves the same town on the same road, traveling at 55 miles an hour. How many hours after the second car leaves will the second car pass the first car? Well, that is what we're basing it on, is what that second car does. All right, so how do we know? Well, we set up a table right here. The table is acting as nothing more than a prop to help us understand what's going on with all of this. So we're going to put our rate. So we've got rate times time in this table is equal to distance. According to our formula, distance is rate times time. So what do we have? Well, in fact, we've got one flavor of a kind of problem. We've got the first car leaving the town. I kind of have to draw a diagram sometimes to help me see what's going on. And this first car travels some amount down the road. Right, so we've got our first car traveling down the road here. My best impression of a little car. We've got this first little car tootling along at a nice slow rate of 35 miles per hour, right? And it leaves town. Then 2 hours later, from exactly the same point, we've got a second car, and it also travels along the same road. Only this time, it's zipping along at 55 miles per hour. And so our second car right here, maybe it's one of these nice little sports cars here. I'll try to draw a sports car there for you. Zipping along here at 55 miles per hour. All right, so he's traveling along. Maybe it's one of these country roads. He decides he's got to take it fast. So, what do we know? Well, distance one, in this case, the distance from the first driver, will be exactly the same as the distance from driver number two. So let's look at our first car. Let's look at our second car. First car is traveling at 35 miles per hour. The second car, of course, traveling at 55 miles per hour down here. Okay. We're basing this, we say how many hours after the second car leaves. So let's call that T. We say T hours. He's driving T hours. We don't know how many hours T is, but that's how long the second car is driving, right? The first car is driving 2 hours more because it left 2 hours early. Right? So on the first car, we're going to get T plus 2 hours, whatever that is, right? Rate times time equals distance. So this says multiply across. So 35 times t plus 2, this is the distance from car number 1. Then we look at car number 2. It's traveling 55 miles per hour for t hours, as we said. So that's 55 times t. So distance 1, distance 2 is 55 times t. And what we know is that distance 1 equals distance 2 equals, leaky pen, try it again, distance 1 equals distance 2, which is to say that the car traveling number 1, that's 35 at t and 2 more hours, will be equivalent to our second car traveling at 55 miles per hour for just t hours, less time than the first car. All right, well, now we've got a nice equation to solve, so let's work this one through. we've got 35t plus 35 times 2, that's 70, will equal 55t, our second car's distance. So now we solve. Let's subtract that 35t from both sides of the equation. 35t. When we do the subtraction right here, we get 70 is equal to, let's see, 55 minus 35, that would be 20 times t. Well, we want to isolate t in this equation here, so we divide both sides by 20. Divide by 20. We get 7 over 2 if we reduce that fraction is equal to t. But 7 over 2, most people don't express time in terms of fractions like 7 over 2. So let's see if we can interpret that a little bit better. We know that 2 goes into 7 3 and 1/2 more times. So let's say t is equal to 3.5 hours. So our answer is going to be what? 3.5 hours. After car 2 leaves, is it going to catch up with car 1? Right? So we want to put that in context, right? How many hours after the second car leaves? Well, 3.5 hours after the second car leaves. That's our answer.